Hello student, I am Dr. K.SINHA, Professor of Chemistry. Today I will continue electrochemistry. Last class I have discussed some numericals. Now other numericals I want to finish. And these numericals are based on the formula E cell is equal to E cathode minus E anode. And last class I have discussed that was based on Nast equation also. But today's class, all numericals will be based on that E cell is equal to E cathode minus E anode. And also you can tell E cell is equal to E right hand side electrode minus E left hand side electrode, or in shortcut ER minus EL. L means left hand side. Now first numericals I am discussing. Question 1, today's class first question. The standard electrode potential of the two half cells are given below. These are the half cell. Nickel 2 plus 2 electron, it is giving nickel. Its standard electrode potential is given minus 0.25 volt. And other half cell reaction is Zn2 plus 2 electron. Here its standard electrode potential is minus 0.77 volt. You have to calculate the voltage of the cell formed by combining the two half cell would be. Actually today's class is multiple choice question, but without solving you can't tell the answer. Okay, answers are given, it is multiple choice question, but simply you can't mark, you have to solve it. Then first option is given, means the voltage means EMF of the cell formed by combining two half cell would be first option 1.0 minus 1.02 volt, second 0.52 volt, and third plus 1.02 volt, and fourth 0.52 volt. How will you tell this which one is correct? Which one is correct? Without solving you can't tell. Simply you can't guess. Okay. Then better just to apply the formula E cell is equal to E cathode. E cell is equal to E cathode minus E anode. Then here last class also I discussed. In today's all numericals, same formula you will use, same concept you will use. Then here, cathode and anode, which one is cathode? Which one is anode? Then by seeing the value, you can tell which one is cathode, which one is anode. Then here you can still compare the value, this and this. Minus 0.25 volt and minus 0.77 volt. Which one is less? Then this is less and this is more. Then more will be cathode and less will be anode. Then in the place of cathode you should write here minus 0.25. This will be, this is more. This is the cathode. Hence, in the place of cathode, you write minus 0.25 volt. Minus. After that, anode. Then anode is, this anode is minus 0.77 volt. Then here in the place of anode, you write 0.77 volt. After that, nothing is there. Just quickly you can solve. Minus 0.25 minus plus, correct? Then from this you deduct minus 2.5. 0.25, then you will get this value. Means plus 0.77 minus 0.25, you will get 0.52 volt. Correct? Hence here in option, where is that? Second option, B. B is correct. Actually it will take, if you are knowing the concept, then it will take less than 1 minute. 30 to 40 seconds is sufficient. Now next question I am telling you. Next question. Question number 2. Here. Question number 2. The voltage of a cell whose half cells are given. First half cell is Mg2 plus 2 electron. It is giving Mg solid. S means solid. And its electrode potential is minus 2.37 volt. And another half cell is this. Copper Cu2 plus 2 electron, copper solid. Correct? And its electrode potential is given plus 0.34 volt. Two half cells are there and both half cell electrode potential is given. Now you have to tell the voltage of the cell, means EMF of the cell. Voltage of the cell means in indirect way, question is asking EMF of the cell, means E cell. Then now again you have understood clearly, two half cell is given. Then quickly you can solve you can solve the numericals and you can get the value of voltage of a cell, means EMF of the cell. Same formula you have to use. E cathode, E cell is equal to E cathode minus E anode. Then here again same way you can find out what is the value of cathode and anode, which one is cathode, which one is anode. You have to find out. Here I want to tell you that you should remember this electrochemical series is there, electrochemical series. Then how elements are arranged, what is the reduction potential value. Reduction potential is standard according to IUPAC. All countries almost who are the member of IUPAC, all are following IUPAC regulation, rules and regulation. Then according to the IUPAC, reduction is considered as a standard. Then that is arranged. Electrochemical series is arranged according to the reduction potential, minimum to maximum via 0. 0 value has been given to hydrogen, correct? H plus, it is converting to half H2, or 2H plus, that is converting to H2. That has been given arbitrary. Its value has been given 0. Correct? Then negative to positive via 0. This you can say reduction potential has been arranged in electrochemical series. Then you must remember, at least for the common elements, common metals, what are their this reduction potential. And then you can say, if you know, then it will be easy for you to find out which will function as anode and cathode. Generally lower, generally what, always lower will be anode and more values will be, that is the cathode. Okay. Then here other technique I am telling you, very easy technique, that by seeing the if reduction potentials are given, then simply you compare the value. Which one is more, that will be cathode. Which one is less, that will be the anode. Then here we can see that here value is minus 2.37 and other is plus 0.34 volt. Then which one is more? Then this is more. Copper is more, plus 0.34. then it will be used as cathode. And it is the minus magnesium, that is a minus 2.37. This will be used as anode. Then now again you can put the value in the place of cathode, 0.34. That is the, here you can write E cell is equal to now 0.34, means cathode minus anode. Then anode is minus 2.37, then minus plus, then both you add, then you will get plus 2.71 volt. How much time it will take to calculate? In mind easily can calculate. Then now you can see which is the 2.7 in option. Option is given. That first option is minus 2.03 volt. Second option is 1.36 volt. Third option is 2.71 volt. And last option is 2.03 volt. Then now see, you have solved. You should not guess simply. Just you solve it quickly, you can solve. When you confirm way, you can tell that answer is C. Answer is C, plus 2.71 volt. Okay. Now, actually this question was asked in MSET. This question was asked. Now next question number 3, I am discussing now. A cell constructed by coupling a standard copper electrode and a standard magnesium electrode. Two electrodes are used, copper and a standard copper electrode and a standard magnesium electrodes. Then cell EMF is given now 2.7 volt. This is the EMF of the cell. If the standard reduction potential of copper electrode is given 0.34 volt, then magnesium electrode, you have to calculate what will be the magnesium electrode you have to calculate. Out of two things you are knowing. Then third things you can calculate very easily by following the same formula. Correct? Again question I am reading. A cell constructed by coupling a standard copper electrode and a standard magnesium electrode has a EMF of 2.7 volt. If the standard electrode reduction potential of copper electrode is plus 0.34 volt, and that of you can say that of magnesium electrode is, you have to calculate magnesium electrode. Then don't see the option, directly you calculate. Then now you can see same formula, E cell is equal to E cathode minus E anode, same formula. Then E cell is given 2.7, correct? And E cathode is given 0.34 volt. Then EMG you have to calculate, very easy, correct? Then now easily you can calculate EMG. You have to bring this side, left side, and this should take it right side. Then you will get minus 2.36 volt. Then now you can see the option. Where is this? Then here see, minus, here both are there. Plus 2.36 volt is also given and minus 2.36 volt also given. Then now it is confirmed that answer will be minus 2.36 volt. Correct? And simply actually in mind also you can calculate. It will take 30 seconds maximum. Because you are knowing the formula and you know how to use this formula, quickly you can get the answer. Now next question I am discussing. Actually this question 3rd, what I discussed now, this question was asked in Karnataka CET. Okay. Now next question I am asking, question 4. What is the EMF of the cell EMF of the cell you have to calculate. It is given electrode potential of, they have not given the name of metal. Metal name, electrode name is not given, simply A and B they have written. Then you can understand without knowing the name. Actually you are interested in only in the voltage, not in the name of the metal. Then what here given A, electrode potential of A to A plus means it is losing the electron. What is the oxidation? A oblique A plus. Its value is oxidation potential, whatever you can tell. Its value is given 0.35 volt. And for B, other metal is B. Then B oblique B dash, B plus. This is also oxidation. Correct? Oxidation. Its value is given 0.42 minus 0.42 volt. Correct? Then you have to calculate EMF of the cell. Option is given. First option is given 0.07 volt. Other is minus 0.7 volt. Third option is plus 0.77 volt. Other option is, last option, minus 0.77 volt. Then now same formula again here you can use it. But now here you have to find out which one is cathode and which one is anode. I told you this you can find out by two ways. First, by seeing the electrochemical series. Less value, it is arranged according to the reduction value from less to more via zero, negative to positive via zero. Correct? Then if you are remembering at least for common, then that way also you can understand. But if you are not knowing, then by you compare the value. Then here you can see 0.35 volt, and here is the A is 0.35 volt and B is minus 0.42. Then obviously A will be cathode and B will be anode. Correct? Then now you can apply the formula cathode minus anode. Cathode minus anode. Then again on the one side it will write the half cell reaction, and then cell reaction if you write finally, then in that time also you can write ER minus EL, right hand side minus left hand side. E cell is equal to ER minus EL. Then ER means you are talking about the cathode. Then cathode value is 0.35 minus, and this is the value of anode. Anode value, which is less value. Cathode is more, anode is less. Then minus 0.42. Then minus plus. Just to add it, you will get plus 0.77 volt. If you are not writing, then also it is understood plus. But you make heavy to write plus. Then now just see where is the plus 0.77. Then now you can see here minus is also there, plus is also there. Then see option C, 0.77 volt. Correct? Then this question also you can solve quickly in examination hall. Now next question. Question number 5 I am solving you. The standard electrode potential of Zn2 plus oblique Zn means this is the reduction, and silver this is also reduction, Ag plus to Ag. Correct? The standard electrode potential of Zn electrode and silver electrode are, value is given. For zinc it is minus 0.763 volt, and for silver electrode it is 0.799 volt respectively. The standard potential of the cell you have to calculate. Standard potential of the cell you have to calculate, and it is given, 4 option is given. First option is 1.56, Second option is 0.036. Fourth option is minus 1.562. Fourth option is 0.799. Then now this question also you can discuss only on the same formula. But here you are doing actually practice in real sense, so that in exam you can do fast. Then now again this also you can find out which one is this anode and cathode, zinc and silver. Which one is anode and which one is cathode? Correct? Then by electrochemical series also you can tell, and by the seeing the value also you can tell. Then now you can see, you compare the value, then minus 0.76 and plus 0.799. Then obviously that silver is 0.799. This is more than minus 0.763. That is the zinc. Then here same way for a cathode, silver is used as a cathode, and this is the cathode and this is the anode. Yes, you have kept simply value, and then same way 0.799 minus plus, just to add you will get 1.562. Where is the 1.562? Then option C. Option C is the correct answer. Here I want to tell you zinc and silver. If you see the electrochemical series, then you will find zinc is above the silver. Silver 0.80, correct? And mercury is 0.85, and gold is auric, that is a 1.30. These are the considered as a, you can say, just like you can say inert metal, non-reactive. That's why this you are using silver and gold in ornaments. This is the main reason, because these gold I told you 1.36 you can tell exact way. Then this is a very positive, and gold is 0.80, that is also positive. That's why it will not take part in the reaction. With air and water it will not react. But this zinc, its value is less. Whose value is less, more negative, they will be more reactive. Correct? More reactive. Then here by seeing the chart also, electrochemical series, you can understand. But if you are not, you are in confusion, not remembering, then you just compare values, and then you can understand which one will be cathode and anode. Now this question was question 5, what I discussed, that was again asked in Karnataka CET. Now one more question I want to discuss, question number 6. This question is little long, but you should not fear by seeing the question. Okay, it is actually, this question is set to confuse the student. Okay, and only in the beginning I am telling you, this question was asked in AIIMS, All India Institute of Medical Science, in AIIMS. That's why just your question is like long, but you can solve it very simply, very quickly. Then now I am telling you, I am reading the question. Given electrode potential, okay, electrode potential is given. For this Fe3 plus 1 electron, it will become Fe2 plus. Means this is the, what happened? Reduction value is given. 3 plus is becoming 2 plus. Gain of electron is reduction. Then this value is given 0.771 volt. Okay, reduction potential value is given for iron. Okay, Fe3 plus 2, Fe2 plus. And for other iodine plus 2 electron, it is also reduction, gain of electron. Then 2I minus you got, and its potential is given 0.536 volt. Correct? Then both for iron, ferric to ferrous, that value is 0.771 volt, and iodine to iodide iron, its value is 0.536 volt. Now you have to calculate E cell. E cell you have to calculate. E cell for the cell reaction. Reaction they have given 2Fe3 plus 2Fi, you will get 2Fe2 plus I2. This is the reaction, cell reaction. 2Fe3 plus 2I, that is equal to 2Fe2 plus I2. Actually, when you will add both, first reaction and first electrode reaction, second electrode reaction, if you will add, then you will get this reaction. Okay, you should not be afraid by seeing this. Then this, while this is actually cell, this became the cell. After joining two electrode, it became the cell. Then here cell reaction is this. Now we have to tell what is the EMF of the cell. 4 option is given. First option is 2 into 0.771 minus 0.536. They have given the result also 1.006 volt. This is the first option. It is given in question. Second option 0.771 minus 0.536, that is equal to 0.503 volt. Third option 0.771 minus 0.536, that is equal to 0.235 volt. Fourth option is 0.536 minus 0.771, that is the minus 0.235 volt. See, it looks that it is a very big thing, sir. It looks that the question is very big, it will be very difficult. But now, what I have discussed, simply you can answer in 15 seconds, 15 to 20 seconds. And it is a M questions, M's. Then I will not do anything. You yourself will do very easily. Here, same things, you have to find out which one is cathode and anode, because finally, whatever is given, you have to calculate the E cell. Then E cell is equal to ER minus EL. Then which one will be cathode and anode? Value you can see. Then here 0.77, and this is a 0.536. Then this value is more, iron is more, means cathode, and this will be anode. Then just to put the value 0.771 minus 0.536, just got 0.235 plus 0.235. See here, option C, 0.235. What I have written, same way it is they have given, 2 step they have given, 0.771 minus 0.536, that is equal to 0.235 volt. See, what was the intention for this of the question setter? Their intention was to make fear the student. By seeing, they will think, okay, how can I solve it? But answer is, see, how much time it has taken? Hardly 15 seconds to 20 seconds. One should not be fear from the seeing the question length. You see what is given, what you have to do. And quickly after that you apply the formula. Then see the option how they have made the question complicated knowingly, so that a student should not touch or do something wrong. But if you are knowing the concept, then 15 seconds, or how much time it has taken, now I told you, hardly 15 to 20 seconds. Then now see, you got the answer. Then option C is correct. Next class, now I am stopping over here. Next class again I will continue with other new or different types of numericals. Thank you.